So, the difference in pressure between this point and this point is rho GH, and this difference in pressure pushes the water into the boat. हेलो स्टूडेंट्स, मैं फिर से हाजिर हूँ अपने इस चैनल पर आपके लिए एक नई प्रॉब्लम लेकर। आज का ये प्रॉब्लम फ्लूइड मैकेनिक्स पे बॉयंसी के कॉन्सेप्ट पे बेस्ड है। छोटा क्वेश्चन है, थोड़ा ट्रिकी हो सकता है, एंजॉय कीजिएगा। एंजॉय कैसे करेंगे? प्रॉब्लम सुनने के बाद खुद सॉल्व करने की कोशिश कीजिएगा, जब ना हो तब मेरे सॉल्यूशन को देखिएगा। और वीडियो के अंत में लाइक करना मत भूलिए, चैनल को सब्सक्राइब करना मत भूलिए। आइए देखते हैं आज का हमारा ये प्रॉब्लम। क्वेश्चन में बेसिकली ये कहा गया है कि देयर इज अ स्मॉल होल at the bottom of a rectangular boat. There is a rectangular boat and there is a small hole at the bottom floor of the boat. This allows the water to enter into the boat. As the boat sinks into water, plot a rough graph showing how the rate of water flow through the hole varies with time. Assume that the boat remains horizontal as it sinks. As the water will go inside the boat, it will sink. So, you have to plot a graph showing the rate of water flow into the boat through this hole versus time. How is the rate of water flow, volume flow rate of water changing with time? You have to plot it with time. So, you can pause the video and try the question yourself. Okay. I'll keep solving the question, no doubt. Just think that this is our empty boat. It does not have any hole. For a moment, let us think that there is no hole on the bottom of the boat. This is the boat and it is made of some wood. It can even be made of some metal, no doubt about it. Are you sure? If it is a metal boat, will it not sink? No, it will not. Think over it. Why? Anyway, so this is our boat and let us say it has got some weight. If it is empty, there is no water inside it, there is nobody sitting inside it, then it will have to displace some water so that buoyancy force balances the weight of the boat. Weight of the boat here means weight of this material, isn't it? If it is wood, weight of wood. If it is steel, weight of this much of steel. Let us say it is balanced by displacing this much amount of water. What am I trying to tell you? If the boat has been placed in this pond, this boat has displaced exactly this much amount of water, this much amount of water. And this much amount of water, if you weigh it, if you find the weight of this much volume of water, this volume of water will have same weight as that of the boat. That is why it is in equilibrium. The buoyancy force is equal to weight of displaced liquid. So, weight of displaced liquid, if I take this much volume of water in a separate bag and weigh it, then weight of that water will be same as weight of the boat. That is why it is in equilibrium. Now, the question says that there is some hole that has been punched at the bottom of the boat and therefore, water starts going into the boat. So, after some time what do we see? What do we see? There will be some water. Here it is no water, right? This is blue one is not water. I have just shown it that this is the volume of water that the boat has displaced. Here it is all air, nothing is there. Okay. Now, when some water enters into it, the boat sinks a little bit. Let me exaggerate it. Okay, it is fine. Let us say this is our boat and there is some water inside it. There is some water inside it. I will show the water in white color, let us say. Let us say this much amount of water has already entered into this boat. Now, for equilibrium, it is necessary that the buoyancy force is equal to weight of this empty boat plus weight of the water inside the boat. Let us say weight of the boat is W. So, the water that was displaced earlier, this blue one, it also has weight W, right. Now, there is some water inside the boat, white one. So, weight of this white water, this also needs to be balanced by buoyancy, then only this thing will remain in equilibrium, right. So, let us say weight of this much amount of water is W dash. Now, to balance this weight of water, how much water needs to be displaced? Same, this much volume, water. This is additional weight inside the boat now, weight of the water, white water. So, how much water needs to be displaced to balance that weight, additional weight? Answer is the same volume of water needs to be displaced. Okay. So, the boat which was earlier drowned, which was inside water to this depth only, now it will be inside water to some more depth, right. Now, you can easily understand that this volume will be same as this volume. Can you understand this? Because this volume of water has a weight that is equal to weight of this boat, the steel used in the boat, and this amount of water will be balanced when boat displaces same volume of water. So, okay, this is the same volume of water that the boat is displacing, additional volume that the boat is displacing. So, this volume of water displaced is equal to weight of boat, and this volume of water displaced is equal to weight of this water which is inside the boat. Therefore, this total volume of displaced water is equal to weight of the boat plus weight of water inside it. बोट के अंदर जो पानी है उसका वेट और बोट का वेट दोनों को जोड़ करके जो आया उसके वेट के बराबर लिक्विड को डिस्प्लेस करना होगा. सो यस, दिस लिक्विड हैज गॉट सेम वेट, isn't it? So what do we see actually? We see that this the level of water inside the boat and level of water outside in the pond, this difference will remain constant, because if this is H here, it is H here also. The difference in water level inside the boat and outside the boat, it will remain constant. So after some time, when even more of the boat sinks into water, there is a hole, of course. In that case also, the level of water outside, I am assuming that the pond is too large. So when the boat goes inside, there is not much of difference in water level in the pond. So this pond water level, I am showing in all my diagrams that it remains same outside the boat. The water level remains same outside the boat in all my diagrams. So if more water is inside the boat, then also this height will not change, because to balance this much weight of water, this much volume of water has to be displaced, which is there, which we are seeing, and this additional volume has been displaced to balance the weight of the boat. So whatever amount of water enters into boat, the level difference between the water outside the boat and water inside the boat will remain constant. Now the question has asked you about the rate of water flow inside the boat. So the rate at which water is entering into the boat, it will depend on, if you have studied Bernoulli's equation, you know, it will depend on the pressure difference between this point and this point. Students, it is the pressure difference which will decide the rate of flow of water into the boat. I mean, when the boat is completely empty, there is a hole. Here the pressure is atmospheric pressure. Can you see that? It's all air inside the boat. And here the pressure is atmospheric pressure, let me call it as P naught plus rho GH. So at this point the pressure is P naught plus rho GH, and at this point just inside the boat the pressure is atmospheric pressure. So the difference in pressure between this point and this point is rho GH, and this difference in pressure pushes the water into the boat. Now what happens after some time? When there is some amount of water inside the boat, What is pressure difference between this point and this point? Has it changed? The answer is no. It is still same, rho GH. Can you see that? Can you see that? अभी भी वीडियो पॉज कर लो, सोच लो जरा भाई. Can you see that? What is pressure here? At this point the pressure is, let me call it P1. It is atmospheric pressure. यहाँ ये सब कुछ नहीं, हवा है. This is atmospheric pressure P0. So sorry. This is atmospheric pressure P0 plus P0 plus rho G, this height of water. Let me call it as Y. So rho G Y. What is this number? This number is actually pressure at this point. ये जो ब्लू कलर से मैंने दिखाया है, ये जस्ट दिखाया है कि this is the volume which must be displaced to balance the weight of the boat. This blue colored zone is nothing, it is vacuum, air basically. So up to this point the pressure is atmospheric pressure, and at this point the pressure will be atmospheric pressure plus rho Gy. Okay. Now what is pressure over here? What is this pressure? P2. Let me call this pressure as P2. What is this pressure? It is atmospheric pressure P0 plus this rho G H plus Y. This whole depth is H plus Y. So what is pressure difference between this point and this point? What is P2 minus P1? What is P2 minus P1? Can you see that? It is rho GH. So initially it is rho GH. Right now it is rho GH. After some time it is again rho GH. So the pressure difference between this point and this point being same, the water will enter into the boat at a constant rate. There is no change in rate of water flow into the boat. So the graph that is being asked, on y axis we are taking rate of water flow into the boat. With time it is not going to vary, it will be a flat straight line. I hope you have understood this. अगर दिक्कत हुई है तो वीडियो दोबारा देख लेना भाई, ठीक है, पर बहुत अच्छे से समझ जरूर लेना. मैं आशा करता हूं कि आप सभी लोगों ने इस क्वेश्चन के आंसर को जरूर समझ लिया होगा. स्वस्थ रहें, मस्त रहें, हंसते रहें, खेलते रहें और फिजिक्स के क्वेश्चन एक एक करके सॉल्व करते रहें. गुड बाय.